In the previous video, we looked at identifying risks. In this video, we will look at part 1 of a two-part video about risk assessment and measurement. The assessment of risk includes deriving measures for the event likelihoods, event impacts, and computing the risks as a product of likelihood and impact. Risk measures, computed as the product of likelihood and impact, are meaningful only if both likelihood and impact measures are ratio scale measures. Before looking at the specifics of likelihood and impact measurement, let's look briefly at what ratio scale measures are and where measures commonly used today fall far short. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. Each level of measurement has the meaning of lower levels plus additional meaning. Ratio level measures are the only measures that convey proportionality and the only measures that can be meaningfully multiplied by one another. Otherwise, the product of non-ratio level measures is mathematically meaningless. Many scales used in practice today, such as the traditional 1 to 5 scale, are not ratio scale measures, and the multiplication of, say, a likelihood of 2 by an impact of 4 is mathematically meaningless and consequently, needless to say, misleading. If you Google levels of measurement, you'll find many references. Here, for example, is a Wikipedia discussion of levels of measurement. In order to measure risk, multiplication and addition are required. The likelihood of an event given a source times the likelihood of the source, the impact on an objective times the importance of the objective, the likelihood of an event times the impact of the event. How do we obtain ratio scale measures or estimates? There are numerous methods in Riskion for doing just that. They include hard data, based on what happened in the past, results of simulations, provided the simulations produce ratio scale measures, fault tree analysis, where there is no historical data to rely on, nor simulation, nor output from other models, judgment, elicited from management, subject matter experts, and the general population, can be used to produce ratio scale measures, provided proper methods are used. Such methods are available in Riskion and include utility curves, step functions, rating scales with ratio scale intensities, pairwise comparisons including a known likelihood, and pairwise of probabilities. For example, pairwise comparisons as practiced in the analytic hierarchy process have been used to produce ratio scale measures for more than 30 years. The priorities, likelihoods or impacts, are derived as a normalized principal right-hand eigenvector of a matrix of pairwise comparisons. Google uses a similar method to derive page ranks. With redundancy, even fuzzy verbal judgments can produce accurate ratio scale priorities. A measure of inconsistency is also available as a check for judgments that might have been made by mistake. We will look at AHP in more detail for the rest of this first part of our risk analysis and management presentation, after which we will look at how it is applied to risk analysis and management in the second part to follow. The fundamental verbal scale of AHP consists of 5 intensities: equal, moderate, strong, very strong, and extreme, as well as 4 between intensities, such as equal to moderate or moderate to strong. Ordinal numbers are assigned to each of these intensities from 1 to 9. As we will see in the next slide, a matrix of pairwise verbal judgments are made between each element being prioritized and every other element. The eigenvector computation of the ordinal judgments can, in most cases, where there's a variety of elements being compared, produce ratio scale measurements of the elements' priorities, even though the judgments themselves were ordinal measures. In this example, we see someone's judgment about the relative amount of consumption of drinks in the U.S. several years ago. The 9 in the first row second column represents a judgment of extreme for coffee more than wine. The 5 in the next column represents a judgment of strong for coffee more than tea. The 1/2 in the last column represents an inverse judgment of equal to moderate, water more than coffee. The elements in the diagonal are all 1s, and the elements below the diagonal are not shown, but according to one of the axioms of AHP, are the inverse of the judgments above the diagonal. Near the bottom of the slide, we see the estimates produced by the normalized right-hand eigenvector. Below that are the actual percentages, which are very close indeed. The same process can be used to derive ratio scale likelihoods for risk sources and events, as well as ratio scale estimates of the impact of risk events on objectives. In the second part of this presentation, we will look at how pairwise relative comparisons, as well as other measurement methods, can be applied to produce ratio scale measures for risk-ion.